Okay, so now we're in lesson 7.4. We're adding, subtracting with binomial and trinomial denominators. So it's exactly the same strategy, except now the denominator gets a little bit more complicated, but we're just going to carry through with the same kind of solution. And here it says, well, let's do the first example. You'll understand it better if we do here. So what we can see here is that the LCD is going to be p minus 2 times p plus 1. So for A, all we want to do is state a couple of things, right? When we state restrictions for A, we can say that A cannot equal negative 1 and 2, and state our LCD just as a reference. It's going to be equal to p minus 2 times p plus 1. Okay? So maybe what you want to do is start off by expressing the fraction with the LCD at the bottom. P minus 2, p plus 1. And then what we can do is take a look at the numerator from the first fraction, which is p minus 1. We take a look at here. In order to get this up to the LCD, we're going to have to multiply it by p plus 1. Then I'm going to stick the sign in between here. I write down the numerator from the second fraction. And then I take a look at the denominator. We'll have to multiply this by to get up to the LCD. It's p minus 2. For step 1, just getting everything up to the LCD. And then in our next step, what we'll do is just FOIL it out. Remember to state it with an LCD. And I'll just bring the final gather like terms up here, and we'll finish it up here. As far as you can go, so you're done. I think for the second one, I'm going to pull this document down a little bit. Now B takes a little bit of planning, and when you see this difference of squares, and it's a little bit backwards from the difference of squares we've seen before, there's great potential for the negative flip trick here. So what we'll do in our first step is just keep the fractions separate for now until we figure out where that negative sign is going to go. Now in order to make the LCD as simple as possible, I'm going to do the negative flip trick here, which makes this a negative and that a positive. So this is e minus 3, that's e minus 3, and that's e plus 3. So it makes the operation a lot simpler when the LCD is simpler. In our next step, what we'll do is a negative times a negative is going to give you a positive. So here we can state our restrictions that e cannot equal minus 3 or plus 3, and our LCD is e minus 3, e plus 3. Okay, so let's rewrite this with our new LCD of e minus 3, e plus 3. And in the first fraction, we're going to write down the numerator, e minus 3 in the first denominator. We're going to have to multiply by e plus 3 to get it up to LCD. So we'll do the same thing with the numerator. In the second one, we see that This is already at the LCD, so we just have to copy down the 3e. Distribute the 2 through the bracket. And then in our last step, we're just going to combine like terms. So that's going to give us, sorry, I'm going to put it over here, 5e plus 6 all over the LCD of e minus 3, e plus 3. Okay, turn over to 232 and try the try the checks, and the answers are provided for you there. Okay, moving on to example 2. Now we're going to have trinomial denominators, and I'm going to need a lot of room for this because it's kind of a longer solution. So I'm going to pull the page down a bit more, and if you don't mind, we'll just go from here. Well, obviously the first thing we're doing for a is start factoring it out. So from here, difference of squares. Now we'll say this to save you a little bit of time. The chances of one binomial in the second denominator being either x plus 7 or x minus 7 is pretty high because we want to make the LCD as simple as possible. We think of the factors of 49 that could give you 14, so we're just going to say x plus 7 times x plus 7, which is x plus 7 squared. Okay, so now we can state our restrictions. X cannot equal negative 7 or positive 7, and my LCD is going to be equal to x minus 7 times x plus 7 squared. So that's this element there. Okay, so we'll rewrite this all according to our new LCD. Copy down the numerator from the first fraction. In order to get this up to the LCD, we're going to have to multiply it by x plus 7. Copy the sign and the numerator from the second fraction. In order to get this up to LCD, we have to multiply x minus 7. Okay, so let's distribute. And finally, we're just going to gather like terms at the end. And finally, we have an opportunity to do a little bit of greatest common factor. Take it one step further. So in questions like this, you need to factor completely. Okay. In the second example, we're going to factor. So this is kind of an interesting one because you can actually reduce the first rational expression here. So these n minus 3's can cancel out. So over here we have 1 over n plus 6 minus n minus 2. Okay, so we know that n cannot equal negative 6, negative 5, or positive 4, and We know that our LCD is 3 binomials, n minus 4, n plus 5, n plus 6. Alright, so just take your time with this one because there's more operations than usual. Okay, so we copy down the element from the first rational expression. We've got the n plus 6, so here we have to put in the n minus 4 times the n plus 5. And then in our second rational expression, don't forget that negative sign. The only one we're missing is the n plus 6, so we'll put that here. Foil everything out. I put the second trinomial in a bracket with a negative sign in front of it because we still have to change the signs inside of there. So that's our next step here. A little questionable if I'm going to have enough room. Oh, it's going to be tight. Make some room over here now. So we'll just take this answer and put it up here. We're just going to combine like terms. There you go. So try to check on page 234. Answers are there and full solutions are in the work text.